At first, one straight line might seem reasonable. But when the pattern changes, one line doesn't tell the whole story. Look closely at the graph. Something changes here. This is the point where one pattern stops working, and another begins. Now we can name what's happening here. One single rule doesn't describe this data very well. On the left side, the pattern is almost flat. On the right side, the pattern changes and starts rising much faster. When different parts of a graph follow different rules, we call this a piecewise model. The point where the rule changes is called the breakpoint. On the SAT, you're often asked to find this point or to compare how the behavior changes before and after it. But to do that correctly, we need to be very clear about what is actually changing. Let's be very clear about what is changing here. On the left side of the graph, the values are not especially low. But notice how slowly they change. The points are almost flat. On the right side, the values may start lower, but the pattern rises much faster. The change is happening more quickly. This is a common mistake on the SAT. Students often focus on how high the graph is, instead of how fast it is changing. Remember this rule. Slope tells you the rate of change, not the height. A graph can be high and still change slowly. A graph can be low and change very fast. When you compare different parts of a piecewise model, always ask yourself, which interval is changing faster? Let's pause here, because this is where many SAT mistakes happen. At first glance, the left side of this graph looks better. It's higher, and it stays above the other part for a while. And that's exactly the trap. High does not mean fast. What really matters is not the position of the graph, but how quickly it's changing. That's the slope, the rate of change. On the right side, the graph starts lower, but notice how steep it becomes. Each step to the right adds much more than before. Another common mistake is judging by a single point. One point can be misleading. The SAT wants you to look at the entire interval and understand the rule that applies there. So remember this. The rule matters more than the position. A steep slope can start low, and a high value can still be changing very slowly. If you keep these traps in mind, piecewise graphs become much easier to read. Now, let's slow down and think about how to judge this graph. When the SAT gives you a piecewise model, your first instinct is often to look at which part is higher. But that's not what this question is really asking. Instead of asking, which part is higher, ask yourself, which part is changing faster? Don't focus on a single point. Look at the entire interval. Over this stretch of the graph, how quickly is the value increasing? In the next question, you'll apply this idea and make a decision. Now it's your turn. Look at this piecewise graph. The question is simple. Which part is changing faster? Don't focus on which part is higher. Focus on how quickly the value is increasing over the interval. Take a moment and decide. Let's slow down and really think about what this graph is showing. When students first look at this picture, most of them focus on one thing: height. The left interval is higher. Its points sit above the points on the right side for much of the graph. Because of that, it feels natural to say, the left interval must be better, or the left interval must be faster. But this feeling is exactly what the SAT wants to test. This problem is not asking which interval is higher. It's asking which interval is changing faster. To answer that, we need to stop looking at where the graph is and start looking at how the graph moves. Now focus on the left interval. As x increases, y does increase, but only a little each time. The points move upward slowly. The rise from one step to the next is small and steady. That tells us something important. Even though the values are high, the rate of change is low. Now compare that to the right interval. The right interval starts lower, which is why many students ignore it. But look at the spacing between the points. Each step upward is much larger. From one x value to the next, y increases more on the right side than on the left. That means the slope is steeper. And slope is the key idea here. Slope measures how fast something changes, not where it starts. So even though the right interval begins lower, it gains value more quickly with each step. This is the SAT trap. Height looks impressive, but it can be misleading. Speed comes from slope, not position. When the question asks about rate of change, the correct choice is the interval with the steeper slope. And in this graph, that interval is the right one. Now let's try an intermediate problem. This one is a little trickier. Two pieces of a graph are shown. Over which interval does the value increase at a faster rate? Don't rush. Compare the change carefully. Now let's carefully explain the answer to this intermediate problem. At first glance, many students choose interval A and that choice makes sense, at least visually. Interval A stays higher on the graph for a long time. The values look larger, so it feels better. But on the SAT, higher does not mean faster. What we are judging here is rate of change, not position. So we need to ignore height and focus on how quickly the graph is rising. To do that, compare the change in y over the same change in x. Look at interval A first. Over this x interval, the graph rises only a little. It increases, but slowly. Now look at interval b over an equal x interval, the graph rises much more. That difference is critical. Even though interval b starts lower, it gains more value over the same distance. That means interval b has the steeper slope. And slope tells us the rate of change. This is a classic SAT trap. Students confuse being higher with changing faster. But those are not the same thing. A graph can be high and slow, or low and fast. The correct choice is the interval with the greater increase per unit of x. That is why interval B is the correct answer. Remember this rule for the SAT. Never judge speed from a single point. Always compare an interval. Now try this advanced question. Two intervals of a graph are shown. Without calculating exact values, decide which interval increases at a faster rate. Be careful, the higher graph is not always the faster one. Now let's walk through the answer to this advanced problem. The correct answer is interval B. Even though interval A starts higher on the graph, interval B increases at a faster rate. To see why, you need to ignore the height and focus only on how quickly the value changes. Look at interval A first. As x increases, y goes up, but only by a small amount. The line is rising, but it does so gradually. Now look at interval B. It starts lower, but as x increases, y rises much more over a similar horizontal distance. That steeper rise tells you the rate of change is greater. This is a common SAT trap. Many students look at the higher graph and assume it must be increasing faster. But height only tells you the value at a point. Rate of change depends on slope, how much y changes compared to x. In this graph, interval B shows a larger increase over the same type of interval, which means its slope is greater. That is why interval B increases at a faster rate, even though it starts lower. When you face advanced piecewise questions on the SAT, remember this rule: never judge by position alone. Always compare how the graph changes over an interval. That habit will help you avoid one of the most common mistakes on test day. Let's take a final moment to lock in how to think about piecewise graphs on the SAT. Throughout this lesson, you've seen the same mistake come up again and again. Students look at where the graph is high and assume that means it's changing faster. But height is just position. It tells you where the value is, not how fast it's moving. Speed, growth, and rate all come from one place: the slope. That's why the SAT doesn't want you to focus on a single point. One point can be misleading. A graph can start high and barely change, or start low and rise very quickly. The only reliable way to compare pieces is to look at intervals. Always ask yourself, over the same change in x, which piece changes more in y? That question works every time. It works when the graph is clean. It works when the numbers are messy. And it works even when the problem is designed to trick you. Remember this mindset. Don't read graphs like pictures. Read them like rules. Each interval follows its own rule, and the slope tells you how aggressive that rule is. If you train yourself to ignore height, compare equal intervals, and judge by slope alone, you'll avoid one of the most common traps in SAT data analysis. That's how you turn a confusing graph into a straightforward decision. And that's how you stay in control on test day.